This is R.D. Sharma solution, class 12, chapter 6, Determinants, MCQ, multiple choice questions. The value of the determinant. So here we see a determinant where we have certain columns that can be added and we can get 1, and then we can just do some row subtraction, column subtraction, and we'll get some zeros. So if you see this b plus c, c plus a plus b, this is the second column. If you add this with the third column, you are going to get ABC, 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 everywhere you'll get, right? Now, when you add these, you can take these common. So a plus b plus c, you can take common. So let me just show you here. So there are multiple ways, as I said, multiple ways to do it. This is column 1, column 2, column 3. So what we are doing is column 2 and column 3 we are adding. We are changing column 2 to column 2 plus column 3. So the middle column will be a plus b plus c. And that a plus b plus c I am taking common. I am taking outside. So only 1, 1, 1 will remain in the second column. So column 2 is changed to column 2 plus column 3. And when we add this, we take a plus b plus c outside. 1, 1, 1. Then we have this a minus b, b minus c minus a. Column 1 will take, if we change column 1 to column 1 minus column 2, what are you going to get? A minus b minus a. So a minus b minus a gets cancelled, you will get minus b. Write minus b here. B minus c minus b. So you get b minus c. C minus a minus c. So you get minus a here. Here you have ABC already. So you can take negative 1 outside. And one more thing we can do. We can exchange the rows or columns so that rather column will be beneficial. So row 1, row 2, row 3, and we'll get rid of that minus 1 also. So I'm exchanging it. I'm exchanging column 1 and column 2. So column 1, we are exchanging it with column 2 so that we get 1, 1, 1 here, BCA here, ABC here. Okay. Because we just don't want minus 1 here. And then A plus B plus C is already, we have taken out. Now you can take 2 rows at a time and subtract them so that you get zeros. So row 2 minus row 1 will do, row 3 minus row 1 we will do. Always in this type of cases, we always do row 1 minus row 2 minus row 1 and row 3 minus row 1. So you get 0, C minus B, B minus A here. I am showing it here only. Row 3 minus row 1 will be 1 minus 1 is 0. A minus B it will be, C minus A it will be. So we'll open it using the first column. So first column will be 0, 0. I am not writing, only 1, C minus B, C minus A here, A minus B, B minus A. So A plus B plus C is already outside. So we get C minus B into C minus A minus A minus B into B minus A. Now you have to do all the multiplication. So A plus B plus C is already there. You have to do proper multiplication and then you have to multiply A plus B plus C also. Means, I am saying A plus B plus C was already outside. We have multiplied C minus B, C minus A. Then we added the multiplication with the result of B minus A and A minus B. Then whatever is coming, we have to multiply again. So when we multiply again, there will be various cancellation. So you will get only 3 ABC, 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 ABC. This is 3 ABC. And A cube, B cube and C cube only will remain. Others all will be 0. Because let's see this BC square. So we have a BC square plus and BC square negative. So you can just cancel it out. Okay. If x, y, z are different from 0 and this equals 0, then the value of x inverse, y inverse, z inverse is. So what will be the answer here? The answer is fourth. How it will come? How we have actually achieved this? So I'm just opening. I'm not making it 0. I will encourage you to do row 2 minus row 3, then row 1 minus row 3. Change row 2 to row 2 minus row 3 and row 1 to row 1 minus row 3. But I am not doing this. I'm just opening it because the way is same. Whatever way you apply, the answer is going to come same. There is no other answer which can be achieved using taking some other steps. So I am not making it 0. I am just doing it all together like this. 1 plus x, then minus 1. I am opening it using the first row. Then we have 1 plus z. Then we have plus 1. So 1 plus y and 1. Okay. So 1 plus x, this has come. I'm just verifying it. And from 1 this has come. Okay. So 1 plus x, and let us solve it. 1 plus, I'm solving the internal one. 1 plus y into 1 plus z minus 1. 1 plus x is already outside. Then minus 1. What do you get? Z plus 1 minus 1. So here you get 1 into 1 minus y. Okay. So this will 1 will get cancelled. It will be minus z. 1 get cancelled. You get minus y. So you have minus y minus z. Now let us multiply this one. I'll just multiply this one. So 1 plus y and 1 plus z will multiply. And then we already have a subtraction 1. So it will be 1 plus z plus yz minus 1. So minus 1 gets cancelled. Now z plus yz, and we will multiply it with 1 plus x. You get z plus yz plus xz or zx plus xy plus xyz. So it is not yz, it is xy. There is a slight correction here. So z and y gets cancelled. You have yz plus xy plus xyz. Now let us divide both sides by, or one right hand side is 0 already, so it will be divided by xyz and xyz. So this will be 1 by x, this will be 1 by y, and as I said, this is going to be, this is not yz, this is because yz, zx we have already taken, so it will be z, because we need x in the z in the denominator. So we have xy here. So I'll just change it. As I said, there is a slight correction here. So the multiplication which we did, there is a multiplication of 1, that was z plus y plus yz. Then we multiplied x with z plus y plus yz. So we had zx, xy and xyz. So finally, I hope you got the idea, right? So finally, whatever it comes, you have to divide it by x plus y plus z. Then you have 1 by x plus 1 by y plus 1 by z. And that is essentially equal to x inverse, y inverse, z inverse equals -1. Right? So this is how the right hand side has come as -1. That is why I am saying it's -1. The fourth option is the correct option. So this is the solution. Whichever way you do, the answer will come as -1 only. The next one. Here we have to see certain factors, and we'll take certain factors common. So this we have b square minus ac, ab minus a square. So we can take b common from here in b square minus ab, and ab minus a square. Let us do the first one first. B, I'm taking b minus a, b minus c here, and we are taking c here. So b minus a it will be. Now next one, ab minus a square. Let us take a common. B minus a minus b it is. Then we take b common from here, b minus a. Here we take c common, you get b minus a. Here you have c minus a. Here you take a common, you get b minus a. So from here, first column I am taking b minus a common. From the third column also I am taking b minus a common. So when we take b minus a common, you will get b minus a whole square. Then you have b, a, c here, b minus c, a minus b, and c minus a here, and c, b, a here. Right? Okay. You can do one more thing here. B and c is already there. So let us subtract the column 2 and column 3 from column 1. So I'll just show you. B minus c, that is b plus c, minus c. So b gets cancelled, c gets cancelled. So you have column 1 we are changing to column 1 minus column 2 minus column 3. And this is 0. Then we have same thing here. A minus a plus b minus b, again 0. C minus a minus a. This all gets cancelled, 0. So other things I am writing, but I can see that one of the column is 0. When one of the column is 0 or one of the row is 0, the determinant will be 0. If x, y belongs to R, then the determinant. So x, y are real. Okay, let us see here. Now you have to see that cos x plus y is what? You need to know what cos x plus y when we open it. Because you know whenever we read trigonometry, trigonometric identities, those formula will be used everywhere. So if you are not able to do it or say prove it properly, just mug it up, because this will be used. So if you multiply the first row with cos y, second row with sin y, what do we get? So row 3 we are changing to row 3 minus cos y into row 1 and minus sin y into row 2. You'll see just now what will happen. We'll get 2 zeros here. How? First I am showing you cos x plus y minus cos y. Row 1 we have cos x. Then we have sin x sin y. So sin x sin y. And if we take minus common, this is cos x plus y. And when we take minus common, you get what? Cos x cos y minus sin x sin y. And which is nothing but cos x plus y. So cos a cos b minus sin a sin b is cos a plus b. It is cos x plus y. You can just cancel it. It is 0. Similarly, minus sin x plus y minus sin x into cos y, minus will be plus, and then minus cos x sin y, that will again give you a 0. And the third column, so it will be cos y with first one, second y, sin y, so you get 0 minus cos y minus sin y. So that will be sin y minus cos y. Okay. Now we'll use the third row to open it. Third row. So sin y minus cos y. Here you get cos x minus sin x, cos x. Cos x, sin x minus sin x, cos x. Right. So you get cos square x and minus will become plus cos square x plus sin square x. So this is going to be 1. Sin square x, cos square x 1. So you get sin y minus cos y. Okay, we have already seen, because we need to know what is the range, you can say, or the boundary. So multiply it by root 2, and 1 by root 2, 1 by root 2 will be here. So 1 by root 2 you can write as cos 45 degree, that is pi by 4. Here you can write 1 by root 2 as sin pi by 4. So root 2 is outside, you get cos pi by 4 sin y minus sin pi by 4 cos y. Because cos 45 degree, sin 45 degree, they both are 1 by root 2. So root 2. So you get cos a sin b minus sin a cos b, that is sin Sine A minus B. So sine y minus pi by 4. Whatever is there, sine theta can be anything, but sine will always be between negative 1 and positive 1. Always. So negative 1, positive 1, root 2, because root 2 is there, so multiply root 2. Root 2, you get sine theta root 2, and this is going to be root 2. So you have minus root 2 to root 2, so this is the first one is the option. Theta is real here. The maximum value of this determinant will be, so whenever we have one row or one column is 1, 1, 1, there is a simple way to do it. Row 2 you will change to row 2 minus row 1, and row 3 you will change to row 3 minus row 1. That is the only thing which we will do, unless until you have something to take common. So R2 minus R1 you will change R2 like that, and R3 will change as R3 minus R1. So 1 plus cos theta minus 1 will be cos theta. 1 minus 1 will be 0. 1 minus 1 is 0. Now coming to second row. 1 minus 1 is 0. 1 plus sin theta minus 1 is sin theta. And 1 minus 1 is 0. 1, 1, 1 will be here. And you can open it using any row or any column. So I am using the third row. So cos theta, it will be 1, 0, 1 sin theta. 1, 0, 1 sin theta. No, 1 sin theta or 0, 1, 0. So 1 into 0 is 0, minus sin theta, cos theta is outside. So minus sin theta, cos theta it will be. So multiply with 2, divide by 2, you get sin 2 theta. Because 2 sin theta cos theta is sin 2 theta. Sin 2 theta by 2. So you have minus half sin 2 theta. I told you sin theta is always between minus 1 and plus 1. Any value. So it will be minus 1 and 1, 1. Since we have minus half, when we multiply minus negative, the sign will change. Inequality sign will change. So I am multiplying both sides by minus half. All of the element with minus half, the sign will change. It is half greater than equal to sin theta. And then we have greater than equal to negative half. So what is the maximum value? It is going to be half. 1 by 2 is the answer. This is the answer. The value of the determinant. Okay. The answer is second, but how does it come? I can see that we can take certain thing common. How? Either you subtract any row or column, you get some zeros, or you can get 1, 1, 1 in any row or column, you will get definitely 2 zeros. So what I am trying to do here is I am doing something different here. I am going to add 3 rows, all of the 3 rows. So because it is going to come as 3x plus 3y. So R1 I am going to change as R1 plus R2 plus R3. So you get 3x plus 3y. X plus x is 3x plus 2y and y is 3y. Similarly here also. 3x plus 3y. So you get x plus 2y here, x plus y, x plus 2y, x plus y and x. Okay. Now you can take 3x plus 3y common. And as I told you, that when we take common, definitely we are going to get 2 zeros. So I am taking 3x plus 3y or 3 into x plus y common. Now, simply column 2 minus column 1 and column 3 minus column 1. We don't do column 2 minus column 1 and we don't do this column 3 minus column 2. No. Column 2 minus column 1 and column 3 minus column 1. So column 1 will remain like that. 1 plus x plus 2y x plus y. Now 1 minus 1 is 0. X minus x plus 2y will be x minus x plus 2y. X gets cancelled. You get minus 2y here. Then x plus 2y minus x minus y. So you get 2y minus y is y. Now call column 3 minus column 1 I am doing. So 1 minus 1 is 0. And you can do column 2 minus column 3, but just I am suggesting the pattern you should follow. Now x plus y minus x minus 2y. So you get minus y here. And then x minus y. You get a minus y here. So we'll open it using the first row. Since we have 2 zeros here. Remember, we have 3 times x plus y already outside. So I am opening it using the first row here. So 1 minus 2y, y minus y minus y. Now you can take y common from here, from first row, first column and second column. So minus y I am taking from the second column, y from the first column. So what do you get? Minus 2, 1 and 1, 1. So minus 2 into 1 minus and minus 1. So minus 3 it is. So minus 3 minus y square was already there. 3 times x plus y was already there. So minus minus gets cancelled. 3 is 9. So you get 9y square x plus y. And that is going to be your answer. Okay. See, there are different ways to do it. But the answer will come same. Answer will not change. This is one of the way. I told you another way. You can also devise your own way. So there is no hard and fast rule to do every question by one way. Okay, this will take in the next discussion. Till then, thank you so much. Take care of yourself.